Okay, let's get started. We invited Vipin back to show the demo that he couldn't show last time because there were a lot of questions. And I think part of the problem is that we try to cover the basics and go into a little bit of detail. So we're trying to do both. So bear with us, but today we'll just see the demo, and hopefully that will give us some practical knowledge of the containers, which is an incredibly important topic. So with that, I will give it to Vipin.
Thank you. Thanks everyone. Can you guys hear me? Okay, some familiar faces for sure. Okay, again, I'll just zoom through slides, so we just revise what we talked about like a couple of minutes. My name is Vipin. So containers we talked is a virtualization for operating system, which means you share the operating system between various applications that are containers. We looked at and said that it is applicable whether containers are running inside VM or on bare metal. It doesn't change the fact that we are virtualizing an operating system here. So then we looked at the fact that it changes the life cycle of application. If you guys recall this slide, it changes the way application is created, and we'll actually create some applications today and see how easy it could be. So with a grain of salt, I'll try to show you the easiest part, but it is not always as easy as I was going to show you. But let's go with that. How do we create an application, build it, push it, deploy it? All those things we'll look at it today. Then we looked at how the ripple effects of containers is affecting the entire stack, right from physical infrastructure, virtual infrastructure, to operating systems. There are new operating systems coming up, to how container runtimes are evolving, to how service discovery is changing the way applications discover each other, and how the orchestration tools are moving on to more dynamic and more agile with Kubernetes and Docker Swarm and HashiCorp tools. And then there are middleware that are having a lot of impact on how you run and deploy applications. Today, people use Chef, Puppet, New Relic, and some of those things to monitor or to deploy applications. Finally, there is repositories that we talk about. So we'll play with some of these things across the board today. So keep that in mind. There are benefits to containerization. We talked about it. It brings consistency. It brings a lot of agility to containers, applications being deployed. We'll see how fast is it to spin up containers and take it down today. And then, scale and efficiency is the benefit we talked about. And then we touched upon why characterizing applications is very, very easy now with this. So I kind of asserted that data center is in transition. So VMs are going to containers, and applications are becoming scale out. Monitoring is going to become active tuning, and monoliths are going to become microservices. Schedule release is going to become continuous deployment, which is, people call it CI/CD, and always up doesn't mean it has to be like that. And so it has implications on the infrastructure, which means it impacts the manageability, networking, and storage, and all that. So finally, there were some challenges I talked about. The scale is a challenge, speed is a challenge, layers is a challenge, and all that. Then we touched a little bit upon what I worked on. I'm very proud of it. Contiv is an open source project, largely sponsored by Cisco, and it does these functions for providing policies for container workloads. I'll leave you some pointers to how to play with this on your own. And these are the components of Contiv. And then this is where we were. Let's understand it live. So what we're going to do is we'll build container application from scratch. How simple this could be, depending on how complex your application is. It could be a very simple thing or a difficult thing. Then we'll try to start, run some containers, and we'll get inside the container and see how the world looks like. We talked about namespaces. We talked about how the world is isolated between different applications. We'll actually get into the container and see that, how to map volumes into containers. We'll go and experiment with that today, and also play with networking. Cisco is a networking company, so how do containers interact with the rest of the world? How do containers interact with each other? We'll look at that today. And then, if time permits, we'll try to deploy containers in a cluster, which is multiple node cluster. So you have, let's say, 3, 4, 5 node, or maybe people in production have hundreds of nodes in their clusters. So you could let scheduler pick where to run the applications. Time permitting, we'll go with that, or try to deploy the application composition. You can do this at your own pace by clicking on this link. I created this just for myself originally, but then I thought that a lot of people can benefit from it. You're more than welcome to play with it and go with that. This is how the tutorial looks like. If you are, like, say, feeling a little bit bored on Friday evening, and instead of going to party, if you want to just play with containers, then download these two things. Download these two utilities, and you are almost ready to go. This is This is made to a level where it doesn't require you to know anything about containers. You know, you can just go ahead and just follow these steps verbatim as is, and it should just work. So what I've done in my just before we started, you know, I downloaded the Vagrant file and I started the VMs, which gives me a 2-node cluster just right here a short while ago. So I have a 2 VM setup which is up and running. So I did this step just before because downloading VM can take some time. But if you have it cached, it's easy. So this is where we are right now in the tutorial. So instead of going through this tutorial, what I'm changing the format a little bit because we are trying to just do the basics of container itself. So why don't we just build an application, for example? Let me just increase this font first. Can you see this? Yeah, I'll show you how to find the link. You just Google Jen Vipin tutorial. That should hit you the first page on Google. Simple Docker tutorial. Okay, and this is what the link is. It is Jane Vipin/tutorial on GitHub, really. Okay, cool. So what we said is that is this font size good? Good. Okay. So once we spin up the VMs, there are 2 VMs that I've spun up on my Mac. You can try it on your Mac or Windows machine. This works on both, so you don't need a Mac for it to run. But we SSH into let's look at the VMs, and they are up and running. So the VMs are no different from standard CentOS VMs, except that I've installed Docker on them, I installed Swarm on them, so you can play with it easily. So we'll SSH into tutorial node 1. So far, nothing specific to containers here. We are just inside a VM like any machine. You can get this machine to be in your lab or on your Mac, or even if you want to try this on, let's say, AWS or something, you could do that. So why don't we create a container? So first thing is that, you know, you see that there are some containers that are already running on my machine. You know, I'll talk about what these containers are. These containers allow you to make a Swarm cluster, which is like 2 nodes are acting like one. So if I issue a command to run a container, it can run on node 1 or it can run on node 2. On the second window, will SSH into node 2. Okay, so so that's our second node. I haven't turned on clustering yet, but you know, we'll just play with one node at a time. So let's write an application, right? You know, let's write a very simple application. Call it hello WIT, right? I've become a Go programmer, unfortunately. So we import a simple packages format, and you know, write a function. So what we'll do is we'll compile this application and make a container out of this, right? Let's make sure this thing runs first. Okay, so let's just add a new line there. So okay, very simple application. All this application is doing is printing something out. It could do all kinds of processing and then do whatever it needs to spew out. We'll look at the logs, how to monitor the logs, and all those things. So I wrote a very simple application called hello WIT. And this application can run on my VM right now, but it's not containerized yet. And this is how it looks like. It just prints hello WIT. So the first thing that I talked about is, you know, Docker and containerization is all about packaging an application. So we have to see what this application needs. Technically, Go applications are self-sufficient binaries. They don't need anything else. So it's a very simple container that we're going to create right now. Let's create a Docker file for this, and we call it from. This is a way to say that you don't have a beginning to say. This application is self-running. We'll look at the size of the container that it builds to create this. So from scratch, we'll copy the file called, you know, the binary. The binary is let's build the binary. So I have a hello binary. If I run hello binary, then this is the same binary that we created. So what I'm going to do is copy the binary into slash in this new container that I'm creating, and I'm going to run this binary inside a container. So that could be, for example, a very simple, smallest container that I could think of, let's say. It doesn't start from any base. What you do is you take a binary and run the binary inside a container, right? You will see this format is called Dockerfile. This format allows you to specify what you want in your application, what environment it needs. Maybe it needs a couple of other libraries to run. Maybe it needs Python version XYZ to run if I'm writing a Python app instead of a Go application. So what you specify in the Docker file is probably, let's just take a look at it, Okay. So this reference tells you what are the clauses you can include in a Docker file. Once you know what those mnemonics are and how you can create an application bundle, it's kind of like encoding MP3, to take my analogy with music formatted application. This is telling you how to encode an application. This is not container. This is a language to say how to create a container. You guys are with me, right? I want to make sure this is a small audience. The best part is that this can be, you can walk away with a great understanding of basics firsthand live. Hopefully it works. The problem with live demos is always like that. But feel free to ask questions. I think we have plenty of time. Unlike last time we started talking about and we rushed through towards the end. So this application needs to be built now. So I've specified a language which is telling me how to create that container. So I'm going to call this container, Jane within hello container, let's say, right? And I'm just saying build a container from a Docker file which is in my local directory, right? So it built a container. Technically, I don't know if you guys saw that. It's almost finished by the time I entered it, right? So it takes those steps to create a container. It says that, okay, from scratch means I don't need anything else to run the container, and we'll create another container which doesn't start from scratch. Let's say if it is not self-sufficient binary. I copy the binary and then I'm saying that, this is a command I need to run. So if I were to do Docker PS now, I don't have Jane within hello application. Yeah, where is the container? Let's look at that. So it is the image that is created. When I did Docker build, it created an image. So when I do Docker images, it tells me that this image is created literally 36 seconds ago, which is, we just created it just now. So, and the size is 2.28 meg, which is, a small container that we created. Question? Where does it put in the file system? You can actually tar zip this container, but the container is of a certain format that Docker keeps it right now in its cache. But you can save it, and which is where we'll get into registry. So for example, if I look at my Docker Hub account, and I've signed into my Docker Hub account here, and you see I have these applications that are publicly that I've created. Remember I was talking about how is it changing, storing, and distribution of applications? This is what I'm talking about. If you go and now if I were to, let's say I created an image, now what do I do with it? The first thing I want to do is push it up so that I can retrieve it wherever I want it from. Maybe I created it on my laptop, but you want to run it on there. The promise of container was that you create it once and you can run it anywhere. So with that promise comes, you have to be able to push these images. So I can do Docker push. First I have to log in into Docker Hub in this case. Okay, it worked. So then I could just push the image which I created. That's the image I had created right up top here, right? So I'm going to push this image, and he's preparing to push the image, and it's a small process of uploading this application, and once it is done, it will be available in the portal. So it created digest, and it says this is the size. Okay, great. So now what happens here is that I can see that this image is pushed now, and I have pulled it only once so far, which is the main operation I did. So what we looked at so far is we took a simple binary, we created a container out of it. We looked at how to look at the container image itself. We haven't started the application yet. All we have done is created the MP3 and so-called saved it somewhere safe. So now I even if my laptop crashes, that application is something you can run on your laptop by calling docker run jane within /hello. So let's do that, right? So this will run the application. So that's what it does. Well, it doesn't do anything more. It just prints the hello message, and that's what it did. Now, let's say that I have these images which I looked at. Let's say I lose this image. So in order to pretend that I'm losing an image, I'm going to remove the image which I created just now. Any questions? So RMI, the remove image command, it's okay if you're not familiar with all the commands, but I'll tell you what it means. So Docker RMI is to remove an existing image from your, okay, so because this container is being referenced, it's not allowing me to delete it. So I have to remove this container first, which was run. Okay, so let's hold on for a moment. What happened? So we ran a container using Docker run, but in the background, what happened was Docker daemon, which is running on this node, created a namespace for this container, created control groups for this container, created PID namespace, created chroot for this container, which is a new root file system, and then ran the application. The output looks exactly same as what we ran from outside, but once we get into the container, we'll see how what difference does it make. Because if I look at my processes here right now in a VM, I have like two processes, which is bash and ps running. I can have lots of processes running here, right? I have I have all these tools and things which are running in the VM. So the namespace of a host is what we are. Once we get into the container, we'll see that container will not see all these things which are running in the underlying operating system. That's because of the creation of those environment that I'm talking about. So again, let's run it one more time, and I'll walk through what is happening here, right? So once we run this container, it creates the environment to run an application and then actually executes the application. Once it is done, it comes out and container is no longer running. If we do PS, the container doesn't show. PS is to, like, PS is a process command for people who are familiar with Unix. It is a way to look at the processes on your Unix system. So Docker PS tells you which containers are currently up, alive, and running. That's different from if a container was running. If you do -A, it'll tell you what containers ran. Now the question is that we ran this container twice, and look at this. Why do we need that? This one exited 26 seconds ago, and this one exited 2 minutes ago, which is approximately the timeline we are looking at here. So in this, why do we need to keep these containers in cache? The reason is because you run an application, it does something. If it wipes out everything, now you wonder what happened. Let's say it didn't work the way you expected it to. So it keeps around these containers so that you can examine their logs, and not only logs. Now you have to give which instance you are trying to look at. So I can look at, this was the logs that was produced by container number 1, which exited 2 minutes ago. I can pick another container to say that show me the logs for this container. Of course, it's going to look exactly the same because we're in the same application twice. So the application ran, it executed, but we are trying to now examine what happened to that container, and we are trying to see what were the logs produced. And this is mostly useful when things don't go right, and maybe in some cases where you want to see when things go even right, you want to check that. So those things happened in just one command, which is Docker run command, and so what I was going to do was next is remove my image, because let's go back and check images. Good question. There was a person. So let's look at the output, right? I think so. You see this cocky Kurtz and pedantic Walhard and all that. So what was happening was that about 2 years ago, Docker would not have these names for if you don't specify a name. So when I run a command, I can specify in Docker run what the name of the container should be. So the way to do that is let's say I'm calling it WIT first container, right? So if I now do Docker PS -A, you see 3 containers. This is the one that we spun up just now. If you don't specify a name, there was a gentleman who contributed to this open source project. He said that he took all the adjectives and he took all the names of the famous people, and they're like he would just mix and match dynamically and give a name, which is supposedly unique over a very long period of time that he guaranteed, and that his patch was accepted. And I wouldn't say it's a it's a pretty good thing. Instead of typing in this A123, I might as well type cocky cars, maybe, you know. So so it gives an automatic name if you don't give one, but you can specify a name to a container. The reason you want to specify a name is because you want to control what that application is looking like when you do Docker PS, when it's active and running. And so next containers will start, we'll give them names. So that's that. So now, you know, what we mentioned was that, you know, if you try to remove the image, it was complaining there was a reference. Yeah, there was a question. Yeah.
Instead of creating.
Yeah.
Is it possible to reuse the existing container which has exited and is no longer running instead of spawning a new one? If, let's say, you have a resource crunch or you really don't want the logs from the previous instance.
Yeah. So, you know, I mean, it doesn't cost you anything to run the container again because the image is already there. The application will start from the main execution thread and execute like anything. You have to create the new namespace for the new container instance anyways. So the work involved in running a container which has been terminated is, you know, going back to my slides, remember I was saying that, you know, this one here, right? You don't need to keep it always up. You can terminate them when you need to because the cost of restarting a container is not much. So it's almost like, you know, you are rerunning an application. So think about it like, you know, if you were to run an application that has run and executed and finished, how would you rerun that application? You have to create the environment for it and run it. So it doesn't cost anything more to run the application again using Docker run command. So I don't think, you know, that you have created a VM and or equivalent to that, you want to freeze that so you could use it later on. That notion doesn't apply here. Okay. So I think what we were trying to do is we were trying to remove the image and see if the place where we push the image can we pull it down or not. And so for that, you know, when we tried to remove the image, it complained that it had references to it, something like. So it says, you know, unable to remove that. That's because, you know, all these processes are using it. So if I were to delete these, you know, remove these containers, then, or I could force it. I could do -F and force this to be removed. Then it'll delete it. Otherwise, it just warns you that, you know, looks like some containers ran with this image. Are you sure you want to delete it, kind of thing. So I can force remove it, or I could have deleted those containers and then started. So what I want to demonstrate right now with this is that, you know, I don't have the image that I created even on the laptop I created. Technically, I've lost that image, but only on my local cache. So the advantage of, you know, going back to, I'll flip back between, you know, what these slides are talking about so we can relate to this. Remember, I talked about the top one, which is container registries. So what I did was, in creating the application, I pushed my application into application repository called Docker Hub. You can push it to Amazon, you can push it to Quay, you can push it to Google Container Registry. Amazon has a EC2 Container Registry. So you can push your image and save it wherever you feel important, you feel that it's safe and secure, or you don't want to expose it. It doesn't have to be these big guys. Like I think, you know, Serpil was asking that, you know, where is it safe? You can actually tarball that image and save it in your, you know, separate secure locker file system if you want to. So there's nothing that, you know, you have to save it at one place. But in order to do that, you have to export that image using Docker save command. So you can give Docker save and you can say that this is the image I want to save. But right now we don't have image. So first we will download the image and then save it so we can save it as a tar file, for example, save it as a binary that you can transport it across. So so if I were to do Docker, you know, Docker run now, first thing it will do is unable to find image and it's downloading that. And then, you know, it pulls this one from the Docker Hub repository and then it runs it. You see the difference here is that instead of, if it doesn't find an application, it tries to find out if it can find it from a repository. That repository is configurable. You don't have to use Docker Hub. You can configure it to whatever your repositories, and you can say that, you know, when I run an application, go check that place and see if the application exists, and if it does, download it, run it. So that's what we did just now when image was. So now I have an image already loaded. If you just want to download an image and things like that, you can do Docker pull, and that'll also download the image, or rather check if it is the latest or not. And if it is not the latest, it will download the image. So very basic stuff with things and containers. Next, I think what I was planning on doing was, going back here. So we did like, we spun up containers, and let's try to get inside containers, because we talked about how the resource isolation looks like. In slide 2, I was mentioning, look, it creates an illusion of an operating system. Let's see that live as to how that looks like. So I'm going to create a different container, because in this container I want to be able to go inside the container and then see it, because this tiny container that I created, which is 2 meg container, was just running and coming out. It didn't give me a chance to get in. So for that, we'll create another Docker file which will allow us to do a shell-based access effectively. It's kind of like SSHing into a VM equivalent. Question? Yeah. Okay, I'll repeat the question. So the question was that, we created image using Docker, and if you have to upload into ECS or Google GCR, which is Google Container Registry, or someplace which is your enterprise local repository, yes, it has to be compatible. That's the promise of the container format. You create it, and I'll be able to run it. So everyone comes to a common ground of what that language is. If you think about shipping industry, that's what containers did. Before, people were just creating, to ship a piano, you need this box. To ship something different, you need a different box. So what they did is, this is the container. Whatever you put in is up to you, and when it gets delivered, it will be delivered exactly the way you put it in. That's what these containers do, which means that the image you create is going to carry its context wherever it goes, and everyone understands that format in a compatible way. So you should be able to not just upload it on these container registries, but be able to use a different container runtime to even run these container images, because the format is what it matters. Comparing with MP3 analogy, who creates MP3 doesn't matter where you run it or where you store it. So, with that. So I'm going to copy this Docker file into back and change this Docker file to, instead of pulling it from scratch, I'll pull it from, Alpine is a Linux distribution, and instead of running this, let me copy it to user bin, user local bin, and instead of running this, I'll just run a shell command here, right? So I changed my container definition. I am now actually taking a Linux distribution called Alpine. You can put Ubuntu or CentOS here, and nothing will change. Alpine is a very short image. That's why I prefer using Alpine during demonstrations, because it's a 2-3 gig Linux distro, which is very small. But what I'm going to do is I'm going to copy my binary into user local bin, which means once I get into the container, I should be able to run this natively. And then my default command is going to be shell script, which will continuously run it. So let's build that, and we are going to call this hello2 maybe. So because Alpine is not found, it's pulling Alpine. See how quickly it built a container for me now again, right? So now I have 2 containers. If I were to look at, I have hello1 and hello2 containers. And if I were to run, you see that it is not really running, in the foreground, because shell is a interactive process. So I have to provide the interactive options here for it to run. And what I'll do is I'll run it in the background. I'll also name it container 1, for the lack of innovative name. And so I made a few changes to previous run. So this time I have run a container. It gave me an ID of the container. So which means if I were to Docker PS now, it's showing me that this container is running for 5 seconds now. And the command it was run with was bin sh, and this is the image it is running. So now we have a container which is long-lasting container, as opposed to ephemeral container that we created just for that ran and went away and we didn't know what happened kind of thing. but now this container is up and running. So stable applications that are supposed to be running for a longer period, let's say a web application or database or anything, which is not a one-time cron job equivalent, you will likely run those applications for a longer period. And this gives us an opportunity to get into the container, what I call it. So remember how we looked at, process ID namespace and all that. So let's try to get into a container. The way to do that is exec is to get into the container. We call it C1 container. So we can, sorry. So now magic has happened already. We are now inside container. What this means is if I look at the PS and PSAUX output, these are only 3 processes I can see inside the container. Remember how in operating system I was able to see so many processes running? I don't see those anymore, mainly because this container has been given a separate process ID space. So from the Linux kernel point of view, whenever I do PS, I'm querying Linux kernel to tell me what processes are running. Because of the namespace isolation, I have been given this particular set of a process ID domain. Imagine getting PID1. I mean, that is given to the first process that starts in the kernel. This PID was given to the first bash shell that was started when I specified my Docker file intent is where I specified this. And I'm running these 3 commands here. So you can see how inside this I'm getting the process ID isolation. Another isolation factor is network namespace. I don't see the interfaces that I see on my VMs anymore, which means that if there are 2 containers running side by side, going back to this picture, it is giving me an illusion of an operating system. It is making me believe that my operating system has only 2 interfaces. It is making me believe that there are only 3 processes running. It is making me believe that I have access to entire root file system. If I look at slash and let's say I nuke, let's say if I remove ls, that will be but I can do that. You know what? Let's just have fun. So we'll remove the entire slash user bin, right? So let's say this is my container namespace. I'm going to nuke everything in user bin, right? Of course, I cannot do ls either now, or maybe it is in the slash local bin, whatever, right? So there's no such file or directory here, correct? So I have been, clear is not there. So now what happens is that, let's say I went in, I can confidently do that because the root file system which is given to this container is not shared by other containers or other applications, which means one of the notions of creating the illusion of operating system is not to give the namespaces with respect to network, storage, and compute, but also to give a new root file system. And then we'll talk about C groups a little bit later as to how you can limit the resources that these applications use. But in this case, I can go and play with these the file system in whatever manner I want, and I'm not affecting not only operating system, I'm not affecting other applications. This is the promise of isolation. If I cannot give this isolation, then technically the promise of giving this illusion is all fake. If a container can actually go and disturb other container in many other ways, then it's not really creating that environment. So since this container is host, what we'll do is we'll get out of this, remove this one, and then restart it, and we'll come back and we'll get back all our files that we had, even though we removed it. Because to answer your question as to why do you not want to run it, maybe you want to start from scratch. The state that a container produces should be saved outside the container, not inside the container, ideally for mostly stateless applications except for databases. So what we'll do is so we look at our processes, and I'm going to remove this container C1. It's removed. If I look at now, that container is not running anymore. So I'm going to write on the same container and still call it C1 because we removed the C1. And I'll Docker exec into C1 now. Okay, so I have all these binaries back. I mean, it's not magic. It's a very simple thing. Basically, the layer of file systems that were created, that were put into the container image, is being rendered back to the container when I do Docker run. That's all is happening. And any of the changes that happen to the file system are not carried along with the container, because container image is what dictates what the container has, not really what runtime changes you make to the file system. If you want to make changes in a persistent way, you have to keep it in data which is persistent, and we'll get into the volumes just very shortly. Okay, so so far so good. We have 24 minutes. Okay. I want to touch networking and storage a little bit. Yeah, question? Yeah. Okay, I'll repeat the question since you didn't have a mic. How do you come from outside the machine to inside the container to access the container, right? So let's rewind back the question into what is accessing a container. What is the meaning of accessing a container? Yeah. Not the main operating system which is running container. So I think it touches into the networking part of it, which we are going to talk about. So there are 3 or 4 ways to interact from and in outside the container. The first method is that you give it a network access. So here, let's try and ping Google, right? I can ping Google from here, and we'll talk about how the mechanics of this is. But since you have access to all the tools that this container provides, you can curl HTTPS, for example. Oh, curl is not there. Okay, good. wget is not there either, probably. Yeah. wget is not there. So if you package appropriate binaries that can pull the content that you want from inside the container, you can do that. But I guess your question is also valid as to how do you do it from outside into the container. I have 2 answers for it. The first one is that do you really want to allow that in a uncontrolled manner? Probably not. You want to allow that based on who can access that container, who can muck around with that application, who has rights to change that application. Copying anything into the content of container is effectively allowing the access to change the runtime of container potentially, if not allowing someone to change the behavior of the application. So if you allow that, then there are 2 ways to do it. The way we did just now using Docker exec. You can get into a container by using Docker exec. You're still not transporting data in or out. To transport data, you have network or you can mount volumes. I can share a volume with container from my base OS. So anything that changes in my base operating system on that particular volume will show up in the container, not anything else. We'll look at that example. So there are 2 ways right now where you can actually transmit in the data into the container or out. Mount the volumes, have the network fetch it or push it. And I think that is by and large true for any compute machine. Even if you take, let's say, VM, how do you get data into the VM? You copy data into the VM using the network interface that is created, or you mount the volume into a VM that, or not volume, you mount a block device into a VM that is accessible from within VM. Okay. I think we are getting into just what I want to talk about anyways. So the question was that, well, for VMs, you know the IP addresses. For containers, you don't know the IP addresses, which is maybe a good thing that you don't have to deal with IP addresses because you just deal with the names. Here, I'm dealing with the name here. C1 is who I want to talk to. I talked about the stack here. There is a layer which I was describing here called service discovery. This layer came into existence because now you have to discover applications using their names as opposed to using IP addresses. Once you know the name of an application, you can say, I want to talk to application called abc.c1 on my Mac or whatever. So once you come up, the next step would be to register your application with a service discovery saying, I'm so and so if anyone wants to talk to me. And once you do that, this layer of tools will provide you a way to identify who you want to talk to and then talk to them. So do you have an IP address? Yes, you do. Can you find out an IP address? Yes, you can. But do you have to use that the only mechanism to access a container? No. So it opens up things where you can name the containers, and based on the name of applications, you can access the application. I mean, it's a right abstraction, in my opinion, for what you want to do it for containers, right? So if you look at the networking, it's given an IP address. This is 172.17.05 IP address, right? Let me just get out of node 1 and get into node 1 and 2 and start another application, start another container. Hello 2, I'm going to run hello 2 again. I'm going to name it C2. The first container we started was C1. So now we have supposedly 2 containers running. One is C1, one is C2. I'm going to exec into C2 now. Okay, so now what you see is this container got an IP address which is .6. The previous container which is C1 got an IP address of .5. Can I have these guys talk to each other? Absolutely. So to answer the question, and it kind of touches back into networking also a little bit, how networking looks like. I don't see the networks that a VM sees. I'm seeing the networks that are given to this container and only this container, and the IP addresses are allocated to these containers. It's a bigger topic as to where the networking is going and what is happening there. But for now, assume that container can have one or multiple interfaces, each one having an IP address allocated to it. And that IP address is what you will use to identify a container. In this case, to get from VM into a container, we are using Docker exec, but we can actually use the IP address of the container itself, provided we allow the host to access the container using the IP address. But in order to SSH into a container, you need to run SSH daemon into the application. So you cannot just SSH into a container if you don't run SSH daemon into the application, like you run it in the VM. So it is unfair to say that I could do SSH into VMs, but I can't do that in containers. Ideally, I would say that I have not seen a case where you have to run SSH daemon into every single container to access the application. Usually, you would just go ahead and get into the namespace of an application to see what application is doing. So by doing Docker exec, what we have done is we have come into the namespace of application to know what application is seeing. This is the world that application is seeing. We just it's kind of like matrix, where you are shifting your dimensions into a different dimension to see what namespace you are in, and then trying to see the world from this dimension as opposed to from the dimensions of the host namespace. So instead of trying to go into the container by traditional methods using SSH or using telnet or using those mechanisms, here we are just shifting our namespace to become container namespace, and now we are in the world where container application is as well. And we looked at the networking, it got an IP address, and we can ping 2 different containers. That's the default mechanism that we use that is given to these applications. However, networking doesn't end there. I want to touch a little bit more on the networking if there are no questions. Is it good? Yeah. So it depends on what networking you are using with containers. And so let's look at that, right? So what I'll do is I'll use a tool which is compatible with Docker images provided by Contiv to spin up 2 containers or 2 different VMs this time, because we spun 2 containers on the same VM. This is both node 1 on both ends, right? Oh, sorry, yeah. Let me remove those 2 containers first. So I removed those 2 containers, and I'm going to get into node 2 on this machine, on this window, and node 1 on this window, right? And the first thing I'll do is I'll create a network, which I'm going to call WITnet, and give it an subnet. Okay, so we are saying, what, I want to create this virtual network, which is given the subnet of 10.2.30.24, and I'm going to call it WITnet. Okay. Net create. Yeah, -s. So what I've done in this case is I've created a network which is given 10.2.30 subnet. And now this network can span multiple nodes, which means if I spin up 2 applications, one on node 1, other one on node 2, they should be able to talk to each other if they belong to this network. So let's go ahead and do that. We ran our previous command command like this. The only difference now is I'm going to specify which network it belongs to. Okay, that's the only difference. You guys can see that, right? Okay, so we're going to start this application. So my first container is started on node 1. I haven't started clustering yet, but on node 2, I'm going to start another container. Let me just copy paste this thing and change a few parameters here. So only thing I'm going to change is name it C2. Oh, well, the image is not there on this node. Oh, hello2 is not pushed. I need to push hello2 from this VM. You saw what problem we ran into? Basically, we tried to run a container on VM2, but it didn't exist on that VM. So think of these two as two different nodes. Even if they are running geographically separate someplace, then it'll look exactly same. So now it pushed the image, so I should be able to run C2 here now. Okay, so it's pulling the container, and now it's running. So we see the container on this node. There is container C2 running. On the first node, I have C1 running. So I have C1 running here. We'll go back and exec into the container like we did before, except for this time, this container is given an IP address from 10 to 3 subnet, which we allocated it to. And I'll talk about where this subnet is coming from. We can exclusively exclude it from getting access to the host at all. This is to be able to get the host access, but this is the network that it belongs to, what we assigned this container to belong to. Same thing if you try to do it here. C2. You can give multiple interfaces. Yeah. Maybe we'll do an advanced session. I like curiosity, of course. It's good. You guys are getting it, so that's good. You can have multiple interfaces in a container, and you can give them different networks. You can have them belong to different networks and stitch them in whatever way you want. So as long as the speed scale. Remember the challenges I talked about. The speed has to be like this. I cannot take go and configure 20 things and come back. So if my speed is not fast, then things are lost somewhere. Because if container takes like about a second to come, and if I take 2 minutes to create a network, it's not going to chime well with people. So like I said in the challenges section here, what are the challenges that we will have to deal with if we are wanting to be successful in containers? And some of the challenges, honestly, as part of Conti's effort, we did work on solving that, and not everything, but definitely a lot of them. So coming back to this, now I should be able to ping this container on 10.2.3. What was it, 2? So that's pinging another container on different hosts now. So this is like multi-host container networking. So imagine I have a web application and database application and a web app and leave it here. So you can have these applications belong to different networks, or maybe one network, and have them access each other. And then to get out, you have this access to get out of the host. There are other ways to get out, which we will talk about how a container can directly connect into a physical top of rack device, which is connected into the network, so that the routes are advertised to top of rack, so you can literally reach out directly from your networking gear, which is connecting to the server. Question?
So Docker has a default networking method itself.
Yes.
Will you talk about a little bit how that works?
That's what we were using before.
Okay.
Until I switch over to netctl commands, okay. It was using standard Docker default networking.
Yeah. How does that work? Does it create a tap interface, or?
It uses something called Linux Bridge to plumb these containers, and I think it's worth looking into it.
Yeah, maybe do a bridge control to see.
Yeah. Let's see. So you can use. I mean, we were using Open vSwitch here, but you can use Linux Bridge. Using brctl commands to look at how Docker is running these containers to a bridge which is running on a host operating system. So going back to this picture, if you were to go back, think of a Linux bridge which is part of operating system, which is the conduit for these containers to not only talk to each other, but to talk outside as well.
In Docker, you tell what to use, the Linux bridge versus OVS.
Good point, good point. So if you do Docker network ls, you will see that we have created, these are pre-built, except for this network, all these are pre-built, drivers. These are called drivers. So what we did as part of Contiv is we wrote a driver for Docker networking, and whenever a network is created through the network which is created through our driver, then it will tell us that, hey, this container is coming up. Do you want to do something with it? Okay, we'll say that, looks like this container needs to belong to this network, so I'm going to give an IP. So all IPAM, creating of the NetDev interfaces, plumbing into the network, plumbing into the namespace of a container is done through the driver. So NetPlugin is the name of the driver that Contiv created, but these drivers are present as a default in the Docker daemon if you don't create anything. So it was using bridge driver when we should have looked at that. In fact, we can still do that. If we do Docker run, instead of C2, let me call this C3 now, and instead of having it belong to WIT-net, I'm not going to specify anything, right? So if I were to do Docker network ls, and let me inspect a network. You know how it shows that these are the containers that belong to this network. Ignore these two containers for a moment. These containers are there to be able to create the Swarm cluster, but this is my C3 container which belongs to this network. So you can see that it belongs to bridge driver. It belongs to bridge network, which is created by its default driver. And that's if you don't do anything, it will do that. But in this mode, you are doing natting on the host, and sometimes it's not good.
What command do you use on the host side to see things from, or you don't?
This is on the host, actually. I'm executing these commands on the tutorial node 2, which is host, not inside the container.
But you're using Docker.
Yeah.
Okay.
In fact,
I was expecting you to use bridge CTL to see the bridges associated.
Oh,
with the
yeah.
container.
We could. I don't know whether I have BRCTL installed here. Yeah. So
that's fine.
we could, if you install the each tools or some of the utilities, we should be able to see that from there. A Linux bridge literally created for it, and it uses IP tables to do the natting.
Yeah.
In fact, if you go to my tutorial, it will actually walk you through all that stuff. Yeah, actually, this is what you were asking. So we inspected the bridge and all that. So here it talks about how IP table rules are set up to be able to give access to each other. This is not Contiv. This is chapter 1 is about Docker default networking. So if you play with it, you will see that.
That's because we're so used to host-centric thinking.
Yeah.
It's going to take us a while.
Yeah. On the other hand, I know as much as we are fascinated with creating bridges and creating these things, the world where applications are, they are less concerned about how it is happening underneath, as long as they're able to talk to each other, they're able to discover each other, and you get the right enforcement of policies between these applications. Question? Web and app and DB layer, yes. Yeah. They do have these layers, except that every layer is, I think the question was that in traditional 3-tier application model, you have web tier, app tier, and database tier. So where does it stand with respect to microservices? I'm rephrasing the question, but what it means is that the promise of going back to my picture here, I said that monolith applications are becoming microservices. What this means is that app tier that you had can run 20 instances of containers on different nodes. I don't have to run one container to mean an application. So I could run 20 instances to call it a microservice, and I can spin them up and delete them as I need to scale out or scale in. So the same model is delivered very differently in case of containers, where a scheduler is going to tell and determine that how much you need to scale. So you'll tell scheduler that I need 10 copies of my web tier because that's the expected load I have. Or I could write a small mechanism to spin up more containers depending on if the incoming HTTP requests are increasing. In that case, if I start seeing a lot of load, let's say during Thanksgiving weekend, spin 100 more. But the infrastructure to be able to predictably do that is what containers are giving now. people used to do that by spinning VMs. So microservices technically existed before containers, as in before mainstream containers came into play. And people are using VMs to be able to do that, and that's how they did it. But with containers, it becomes very agile. You can spin up more instances to handle your load almost dynamically, which means you don't have to always keep it running. Remember, I was mentioning that in my presentation. So always up is not the norm. You keep it up when you need it. You take it down when you don't, which means because the cost of spinning up and taking it down is so low that you want to utilize your resources to your best, which means that if I have 20 containers running that are just doing a loop and not doing anything and consuming memory and consuming my CPU, even if it is little, why should I take on that? So it brings the promise of efficient resource utilization as a result. Okay, I think the time is almost over, but 3 minutes left. So let's try and play with the same container stuff, but using volumes as to how this is all good. We looked at basic networking. I'm going to remove container C1, and this time let's create a directory, export, and I will touch a file in export called. So let us say that an application needs to be given configuration before it is run. How do you give it to an application? Let's say Apache server picks up configuration from at cconfig someplace. How do you do that with containers? Because if you package everything in an application, then I cannot build application once and run it with different configuration in different places. So that's where I think mounting volumes comes in. So I'll take the same example of Docker run, except that let's say we will not make it belong to WIT-net, which we can, but I'm going to mount a volume in this container, which I'm going to call that anything which is export is mapped into export inside the container, right? Sorry, it needs the absolute path. Okay, so now I have run the container, but what will happen, you will see, is that if I exec into my container, sorry, I should have mapped it to import ideally. So export has this. Now this directory, only that particular mount point which I mapped into the container is exposed inside the container, not the entire file system, which means I can have 10 containers mapping different volumes from different things and getting their behavior accordingly. And this is a writable thing, if I were to touch another file called XYZ here, and I see, export. So I have two files here, right? You guys can see that we are inside container and export directory. There are two files here. If I exit the container and look at export, it has created XYZ, which I created inside container. That is another mechanism for you to exchange data from an from inside container to outside world. The difference between the mounted volumes versus the default file system is if you make changes to default file system, that is not reflected when container exits. But when you mount it explicitly, the purpose of this is to be able to provide databases and provide persistent storage, or maybe I want to spew out some logs that I need to persist, things like that. So with that on time, I guess play with it, enjoy, have fun. This is something which you don't need tons of equipment to run and try it out. All you need is just one Mac or one laptop and 1 hour of free time. So have fun. You will start appreciating some of the value. Thanks.
Thank you, Vipin. I hope that was helpful. It went by very quick when we do the demo. Right? So thank you. Next month's announcement I'll send tomorrow. It's going to be a surprise.